Welcome to Earth Science, everybody. Let's talk about the universe a little bit. Building on what we started yesterday, the rest of this will be slightly new. But let's start with this, which you should have available as a PDF in your classroom. What we figured out yesterday is that if stars are moving away, the wavelength of light, as this star moves, that wavelength gets longer and longer and longer. So the wavelength of light increases, which is a Doppler shift or the Doppler effect. And the color of stars goes through something called redshift. Everything shifts equally to the red end of the spectrum. They don't get closer or further. And there was a question yesterday you dealt with that. They just all equally go down towards the red end of the spectrum. The opposite does happen sometimes. As things coming towards us, the wavelength gets shorter, and we call it blue shift. But all in all, we observe a whole heck of a lot of redshift out there, which shows us that the universe is expanding. So this led to the initial ideas of, well, that means that yesterday the universe was a little smaller, and the day before that it was a little bit smaller, and the day before that it was a little bit smaller. And if we follow that back a long time, the universe would have been infinitely small. And so Hubble came up with this idea called Big Bang Theory, where it came from that, and the universe has spread since then, which was like a cool idea, and some people bought it, but it wasn't necessarily, that wasn't proof. Here in science, we need to do more work. We need to take these ideas and build on them, study more, prove, disprove, hone, figure these things out a little bit more precisely. So today, we'll talk about the next bit that really means we live in a Big Bang universe. It's this crazy term, and all you really got to do is be able to recognize it. I'll show you this in a minute. It's called cosmic background. Sorry. Radiation. Radiation. There we go. Close enough. Cosmic background radiation is really further evidence and really, again, put the nail in making this theory pretty tight. All right, so we'll talk about what that is, but I'm also going to be honest with you at the same time. Here's the state standard. All right, so this is the stuff you got to know. And if you just can knock that little nugget in your head and say cosmic background radiation, Big Bang, just associate those two, then you can take the shortcut, you can skip all this stuff, and we can go right down to where we're going to wrap this up. If you're interested in this a little bit, we'll talk about the long way. I'll take a quick trip through how we figured this all out. But this box isn't necessarily something to be tested on. It's really the Regents really just says cosmic background radiation is evidence of the Big Bang. And if you want to stop at that sentence, you're good. You got to come back with me after the end of the shortcut, though. We'll be back in a minute. So Penzias and Wilson, these two scientists, doing some communication studies in this big horn antenna. This is on a hilltop in New Jersey, Bell Labs. They are, let me just make sure I'm recording here before I get too deep in this. Yep, we're looking good. This thing spins all the way around like a big record right there, and then this thing spins all the way around on the other axis. So they can point this thing everywhere, and they basically had this like noise that they couldn't figure out that was in the signal. And they thought maybe it was this, maybe it was that the other thing. So they went and they pointed at New York City, they pointed it away from New York City to see if maybe it's just something that humans are making. They tried a couple of different objects. There was a bunch of pigeons in there. They caught them and they took them away, and they flew back, and then they shot them. And they cleaned up all the bird poop, thinking maybe it was something with that's affecting it. But no matter what they do, they very consistently got this noise on this one spectrum. And as it turns out, what they were really listening to was this cosmic microwave background. But it took a minute for everybody to put their heads together and say, hey, because there was other scientists simultaneously saying, hey, if the Big Bang was a thing, there should really be like a lot of energy still detectable in the universe. Not easily, but there. And then these guys were like listening to that at the same time, scraping away chicken or pigeon poops, wondering if it's that, but they were really like detecting the Big Bang. It was kind of a neat story in the history of science. But yeah, so that's what it was. They detected cosmic background radiation. this energy that's still bouncing around the universe from the Big Bang, that as the universe has expanded, and cooled, it's gone down to a very, very low temperature, but it's still there and it's still everywhere. People still work on this. I had a friend that got to go to Antarctica to work on this, detecting it in different parts of the universe. And in fact, if you've got one of these old analog TVs, digital TVs just go to like a blue screen, right? But if you've got one of these old guys that goes to the static, you detect some of that, like a tiny bit of that, like a percent less, is cosmic background radiation. So you could say, hey, that's it. I'm watching the Big Bang on TV, and not that awful comedy. So, hey, Mr. F, I didn't get all that. We can talk about it, but honestly, again, if I'm going to be honest with you, take the shortcuts. All of your job really is to just associate, to link cosmic background radiation with evidence for the Big Bang. You're going to do a little 10-question classwork that by the time you get to the 10th question, you're going to say, this is repetitive and it's driving me crazy, because basically it asks questions about this and questions about this, and that's about it. There's 9 that do that, and then there's one that deals with how old the universe is. It says over 10 billion years. It's more like 13, 14, 13.7, something like that. I don't know why they just say over 10. It is over 10, I guess, but look for that slightly higher number. Yeah. So to wrap it up, about, well, I think it's 13.7. I mean, this number shifts. Let's see what the internet says today. Age of the universe. 13.7. Hey. That's very sound research methods right there, right? But that's about right. It's about, and as you guys become astronomers and study more, maybe you'll find out that it's a little bit different. So Big Bang, continually expanding universe. So everything in a single point to singularity, and then a rapid expansion. And from this, all matter in the universe is expanding ever since. So like from that like hot soup of energy. If you've ever seen this equation, this is like what they put in cartoons to make somebody look smart. This is Einstein's theory that links energy and mass. But from this, we would basically develop like atoms, stuff, matter, and then eventually stars. Stars are born and die, and a lot of them have planets whipping around them. You live on one of those planets, not plants, plants also, but also planets is what we're talking about. And everything, stuff. And you and I, there's the bell. So you guys are gonna be coming into class here in a minute. All right, so through all of that, expect repetitive questions on this stuff. There's the standard one more time. Expect that. Cosmic background radiation, redshift. Cosmic background radiation, redshift. That's the meat and potatoes right there. You'll see it a bunch. Thanks for sticking with me. We'll see some of you in like a minute here. I'll go open the door. Take care.